Hello students, today we are going to discuss a new question under the topic of discrete probability distribution. Okay, let's look at the question. In a nickel cadmium battery, a fully charged cell is composed of nickelic hydroxide. Nickel is an element that has multiple oxidation states and that is usually found in the following states. Okay, don't think that this is some kind of tough question because of the details given in the question, just like nickel, cadmium, nickelic hydroxide. Don't think about those things. What you have to focus is how we can identify the correct probability distribution here. Okay, look at here. 0, plus 2, plus 3, plus 4. What do you feel that? Those are just discrete values, right? So if we think that nickel charge as x, so that is our discrete random variable. Okay, so here x 0, 2, 3 and 4. Proportions found. They have given us some proportion values 0.17, 0.35, etc. So this is the probability of each x. There's no problem of thinking like that, right? So you can just write down the probability values like this: 0.17, 0.35, 0.33, 0.15. Yes, now you see that discrete probability distribution. We just substitute the x and px values to this table, then we got our discrete probability distribution. Okay, next we should find out whether it is a valid probability distribution or not. Okay, we should check two things. Okay, first one is probability of given all the x values should be equal to 1. Sum of all the probability values for each x value should be equal to 1. So 0.17 plus 0.35 plus 0.33 plus 0.15 should be equals to 1. Yes, that is equals to 1, right? Okay, now that condition is satisfied. Next one is each probability value for particular x should be in between 0 and 1 inclusively, right? Yes. Shall we check that one? Yes. Look at here. The probability value for x is equal to 0 is 0.17. That is in between 0 and 1, right? This is also in between 0 and 1, 0 and 1, in between 0 and 1. So the second condition is also satisfied. Now we are good to go to the question part A. What is the probability that a cell has at least one of the positive nickel charged options? Okay, at least one means you can have more than one positive nickel charged options. Okay, these three are the positive nickel charged options. Then at least one means you can have maximum value even, right? You can even have the maximum value. That means all three. So Px is equals to 2 plus Px is equal to 3 plus Px is equals to 4 is the answer for the part A. Okay, let's look at that one. Okay, this is the answer. These are the probability values for each x value. Then if you add those together, then the value for the given question, answer for the given question is 0.83. But I'm going to teach you some kind of shortcut or some kind of interesting method to find that one. Okay, you know that all the probability values for the given discrete probability distribution should sum up to 1, right? This is how we write down that one. If you write what is the meaning of this sigma I is equal to 1 to 4 pi, then it is this one, right? That should be equal to 1. So for the question 1, what is the desired part? That is probability x is equal to 2, probability x is equal to 3 and probability x is equal to 4, right? This part, you should calculate the sum of this part. Okay, keep that part in the left side and move the other parts to the right side. Do the proper mathematical calculations. Here, this one is positive. P is x is equal to 0 plus value. So take that into the right side. So 1 minus probability x is equal to 0. So instead of adding all these 3, okay, this is just reducing 0.17 from 1. So that is easy to get the answer. You will feel there's no matter. It's even easy to add these 3. Yeah, but what happens if you have the x values something like this? When it comes to this kind of big x values and some kind of each probability value for those things, just like this, what will happen? Yeah, taking all the sum is kind of difficult. Using this type of method is easy rather than using that method. Okay, that's why I told that one. Okay, let's look at the second part, part B. What is the probability that a cell is not composed of a positive nickel charged greater than 3? Greater than 3 means Px greater than 3. Okay. What are the values available x greater than 3? Only one value. That is probability x greater than 4. Right? The question is not asking about x greater than or equal to 3. Okay? It is not something like that. So, just greater than 3. Therefore, we have only one value, x is equal to 4. Right? But what they ask is not the probability of this one. Right? What is the probability that a cell is not composed of? Okay, that means the desired probability for the part B should exclude the probability of x is equal to 4. Understand? Okay. Now, how we can find that one? Then, we should add all the probability values without x is equal to 4. Right? This one. Again, you know that this one. We can write this in this format, the extended version of the sum of all the probabilities. Okay. Now what they ask is this part. Isolate that part in the left side and carry this into the right side. Okay. If you carry that one into that part, if you do that one, the answer for this one is 0.85. It's easy to find using 1 minus thing than adding all the values. Okay, hope this is kind of interesting application of discrete probability distribution and hope you guys enjoyed this one. So subscribe me for more videos and let's meet with another video.